what you want to do is the first thing you want to do is you want to find the least common multiple.
They're so mean.
Least common multiple.
It's like shadowing.
Okay? That's why you guys have it on paper, so you can look there and not criticize everything that I put up on the screen. Okay? Okay. Well, I guess we're looking at your test. I'm sorry, is that a 2 or a 5? I can't tell. Wrong! Okay. So what you guys want to do, the first thing is you want to find your least common multiple. Now, the thing is with your least common multiple, it has to be from both sides of the equation. So in our case here in example 1, what's our least common multiple? It is not 2.
It's 1.
It's not 1. You're thinking of the greatest common factor. It is 6.
Yes, I was right. Sorry.
Okay? What you need to do next, as we pay attention, is we need to multiply by the least common multiple. Remembering, of course, that whatever we do to one side, we have to do to the other. So we're going to multiply both sides of our equation by 6. Well, ladies and gentlemen, what do you get when you take 6 times the rational expression x over 3? No. 6x over 3, which reduces to?
I have a question. Why can't you do it where you multiply?
Okay. Meanwhile, back to our work. 6 times x over 3. Again, what is it? I've heard 6x over 3, but it needs to be simplified. 2x.
I'm actually trying to.
What about 6 times x over 2? What is 6 times x over 2? Good. 6 times 10. Solve. Correct. We can combine these like terms because they're both x's.
So are we just solving?
Yes, ma'am.
Do we need to write down the explanation?
We would have to make sure and think about restrictions. Do you have a variable as a denominator? Therefore, you're okay.
Yeah, why?
It's on the video. We have to check the solution because x equals 12 is a solution of this equation right here, but it might be extraneous where it doesn't work in the original. So to check it, you just simply plug it in. So it's 12 over 3 plus 12 over 2. Guys, what is 12 over 3? 12 over 2? 4 plus 6?
What would we do if it wasn't extraneous?
Are we going left to right?
We're going to go to the one in the right corner. So we're going here. Now, this one's slightly different than the first because in the first one, we had the addition of 2 rational expressions on one side. In this example, we just have a rational expression equaling a second rational expression. We can do this like we've always done it. We can use cross products. So that means we're going to multiply the diagonals. So 3x times 3 and 4 times 5x plus 1. We can simply find the cross products. Ladies and gentlemen, of course we all know 3x times 3 would be 9x. Here we get 9x plus 4 would be 20x. Thank you very much. And now we just solve. So again, it's just a nice linear equation right now, so we'll just simply take this over. And we get that x equals negative 4/11. How we doing? Again, find me your least common multiple for this example.
30.
30 is correct.
That was first.
Remember, not the greatest common factor. I don't care what goes into them. I care what they all go into. And it has to work for both sides, so therefore it has to be 30. It can't just be 12. It's got to make sure everything goes into it. So, once you found your LCM, again, you want to multiply everything by the least common multiple. And the reason why you want to do that is because, as you saw in the first example we did, it clears all the fractions. So, ladies and gentlemen, what is 30 times 2y over 5?
60y over 5.
Which reduces to?
12.
Yes. 12y. Again, I prefer to cross cancel. Nothing's wrong with what Liz said, but I think it's easier if you would go 5 into 30 is 6 times. 6 times 2 is 12. 6 into 30 is, and then times the 2. You guys are a little ahead. That's all right. 2 into 30?
15.
6 into 30.
5.
Very good. Does everyone see where all that came from?
How did you get it?
All right, so now as we resume, notice that when you've multiplied by the LCM, you've cleared all the fractions out. So now our goal is to solve this nice linear equation for y. So I'm going to subtract 12y and add 5 on the other side. We think that y equals 5.
How hard are you playing?
Again, we check it. 2 times 5 over 5 plus 2 over 6. Guys, what's 2 times 5?
10.
Divided by 5?
2.
So yeah. Do you guys agree that would really be 2 1/3 on this side?
Sure, yeah.
And then if we put it over here, 5 over 2 minus 1 over 6. If we're going to subtract 5 over 2 minus 1 over 6, what do we got to get? So would you guys agree this would be 15 over 6? 2 1/3. Since both sides equal 2 1/3, it does in fact work. In this example, again, we can't just simply cross multiply because it's not two rationals equal to each other. We do in fact have to work out for the least common multiple, but in order for us to work out for the least common multiple, we have to factor some things. So, how would you factor 2x plus 2? How would you factor x squared minus 1? And the x minus 1 won't factor. So ladies and gentlemen, answer me this.
Wait, is that x plus 1 x minus 1?
It is. What's your least common multiple going to be here?
X minus 1.
Is part of it.
X plus 1.
Is another part of it.
2.
And 2. Now, if you've noticed in the previous examples that we've done, when we multiply by the least common denominator, or least common multiple, excuse me, we're canceling things out. So ladies and gentlemen, as you look at this first term, right here, what does it not have as a factor that the LCM needs?
Negative n x minus 1.
So therefore, it's going to be 1 times x minus 1. Because if we multiply by the least common multiple, the 2 and the x plus 1 would cancel out. And you just have x minus 1. When you multiply the second term by the least common multiple, what's going to cancel out? Or what's going to be left, I should say?
Nothing.
2.
2. How?
So this isn't like the addition one where we put it over in fractions.
Right.
We just leave it.
You have to do that to both sides, man?
You do.
Oh, God.
So over here, what's going to be left? Okay. Here we go. So, of course, this is x minus 1 plus 10, and using the distributive property over here would be 2x plus 2. Again, it's a nice linear equation. X plus 9 equals 2x plus 2. You guys should be able to tell me from here what's x equal.
7.
Very good. And once again, you would go back and you would check it by putting in 7. What also helps too with these, if you look at our least common multiple, because all these are in the denominator, what can x not be? Look at our LCM. If x minus 1 is a factor, what can x not be? X can't be 1. X can't be... Oh, x can be negative too. It can be 0. It can be 2. Notice 2 is a constant. So no matter what you put in for x, you're never going to change 2. It's always going to be 2.
Oh, so I'll remember.
So again, in order... Ooh, what did I do? I know what I did. Okay, I forgot to hit this. All right. We need to find the LCM, which means we need to factor everything that we can. So that means we need to factor the x squared minus 9. Now, notice that this term right here almost appears to have x minus 3 for the denominator. Would you agree that 3 minus x is the complete opposite of x minus 3? So therefore, I'm really going to take a negative 1 out of here. Then I can make it x minus 3. So ladies and gentlemen, what is our least common multiple?
X minus 3.
And? Very good.
Okay.
Ladies and gentlemen, hang on. What can x not equal?
3 and negative 3.
Very good. All right, ladies and gentlemen, our first term, what is the factor of the least common multiple that it doesn't have? So it's going to be 2 times x minus 3. What does the second term not have? Very good. What does the last term not have? Nothing. It would just be 6. We do. Distribute those, that is. Combine a few like terms. I'll await a final answer from someone. No. Negative 9. You'd have to add 21 to both sides. Is that one of our restricted values? So I feel pretty confident that's going to be correct. And of course, we can check it. One delivery driver can complete a route in 6 hours. Another driver can complete the same route in 5 hours. Let n be the total number of deliveries on the route. Write expressions to represent the number of deliveries each driver can make in 1 hour. I took B out. Ladies and gents, what do you think?
There's a formula for this.
I know they're learning now.
Okay. So, write expressions to represent the number of deliveries each driver can make in 1 hour.
Not enough.
Guys, how many deliveries are there?
2.
N. How many hours does the first driver take to complete the route?
6.
What's his expression?
Oh, so n plus.
Plus 6.
No. What?
So like you could do it like n plus.
No.
1 over 6.
6 over 6 over 9.
No. How many deliveries does he make?
And
How many hours does it take him to make the deliveries? So it's n over 6. The second driver completes the same route in 5 hours, so his expression would be n over 5. Very good. Okay?
How do we solve that?
Here's the classic question. If the drivers work together, about how many hours will it take them to complete the route? Well, let me ask you this. Okay? You are correct. Okay. If the drivers work together, so if they're working together, what are we going to do with their rates? Add them. Very good. They're going to complete the route. One route. First driver takes 6 hours, so his rate is one route in 6 hours. The second driver is one route in 5 hours. How long does it take them to do one route together?
Just cross multiply.
Not quite.
Would you find a common denominator?
I would find a common denominator. Matter of fact, what is that LCD?
30.
30 what?
X.
Very good. So we're going to multiply each thing by 30x.
Would it be like 30x over 1?
It would be 30x over 1. Ladies and gentlemen, what do you get when you take 30x over 1 times 1/6?
5x.
Very good. What about 30x over 1 times 1/5?
6x.
What about 30x over 1 times 1 over x?
30x.
30.
By the way, what is 5 plus 6?
11.
This is where AJ was saying you multiply their rates together. Because to finish this up, we divide by 11. 5 times 6 divided by 5 plus 6.
2.7.
Round to the nearest tenth. Working together, it would take them 2.7 hours. Is it the one concept? Okay, we're draining one fountain. Well, the first valve, its rate would be 1/4. It drains one fountain in 4 hours. The second fountain drains it in 5.25 hours. We're going to drain one fountain together. So again, here's our least common multiple. It's just every factor that's in the denominator. So ladies and gentlemen, when you multiply this first term, 1/4 times your LCM, and again, think about how I said this earlier. What does this denominator not have that this one, the LCM, does?
5.25x.
So this is going to be 5.25x. This,
4x.
very good. And this,
4 and then 5.25.
okay, thank you. This is where AJ was saying the formula that Ms. Heff showed you is that you're multiplying the two rates together. Over here, notice that when we combine the like terms, we're going to be adding those two rates together. And then we'll always be dividing them.
Is that 9.25x?
It is. So from here with your calculators,
2.27.
It's 2.3. 2.27 is 2.3.
okay?
I'm supposed to go into the first chapter.
And it does say it's 2.3 hours.
I did my math wrong.
Okay. Together, the machines make 1,500 pens during an 8-hour shift. Machine A makes pens at 2.5 times the rate of machine B. About how many hours would machine A need to make 1,500 pens by itself? Okay. Well, let's see.
Wouldn't you like double it?
So, here's machine A. Do we know how fast machine A is going? So we're going to call it, sounds good, plus machine B. Now machine A makes pens at a rate 2.5 times
So 2.5x.
2.5x.
I don't think in 1,500 together.
No.
Okay? No, together they make 1,500,
Yeah.
We're trying to figure out.
and they make 1,500 in 8 hours. But the question wants to know how long does it take to make 1,500 by itself, so it's still the 1,500. Okay? So here's machine A, here's machine B. We put them together, and we get the combined rate of 1,500 tens in 8 hours. 1,500 divided by 8. Okay? So again, your LCM definitely is going to be 8 and 2.5 and x. So when you guys do this first one for machine A, what does machine A's denominator not have that the LCM does? So it's 8 and 2.5, and then your 1,500 is still there.
Isn't that just 20? And then times the.
Would be 20,000. Agreed. Your middle term is just the 8. And over here, 2.5x.
Why do you have 1,000?
Yeah, why do you have 1,000 instead of 1,500?
Yeah.
Because I was seeing who was paying attention to see if I wrote that right. So, Ashton, good job. You get the gold star for the day. So that's probably going to come out to be 30,000 then, isn't it?
Yeah.
Okay, thank you. Anyone got 8 times 1,500? Sounds pretty reasonable to me. Confirm my math. Is that 3,750x? 1,500 times 2.5?
3750.
Thank you. So I can put these together and I get 42,000. We'll divide it by my 3,750. Guys, what's x? 11.2. It's an exact answer, so I can get rid of my approximate signs. What's 2.5 times that?
Why did you multiply it by 2.5? Is that for
Okay, hold on. I'm pushing the limits of how much